Greetings. Up to now, we've been using the famous forms method in order to identify valid arguments. However, as we've noticed, the famous forms method only helps us to identify certain valid arguments. There are others that it doesn't help with, and it provides no way at all for recognizing invalid arguments. Informally, we've introduced the method of counterexamples, of showing that an argument has a counterexample and therefore can't be valid. Today, however, we're going to go beyond that and try to illustrate ways in which to turn that method into more of a science than just an art. There'll still be something of an art to it, but we can be much more specific about how to go about it. In order to get started, let's remind ourselves how counterexamples work. Valid argument forms always take you from true premises to a true conclusion. In other words, when the form is valid and you start with true premises, you always end up with a true conclusion. Now, if you can find a substitution instance for an argument form with true premises and a false conclusion, that means the argument form is not valid. So, if you're not sure whether an argument is valid, you find the form and look for a substitution instance with true premises and a false conclusion. Ideally, these should be well-known true premises and a well-known false conclusion, because if it is, then it will be clear to just about anyone that you've gone from true premises to a false conclusion. And this, if you can find it, is a counterexample, and it shows the original argument was not valid. The reason it does that is because validity is a matter of form. If two arguments have the same form, then either they're both valid or they're both invalid. It can't ever be mixed. So find another argument with the same form, with true premises and a false conclusion, and you've shown that's not a valid argument, and therefore neither was the first argument. Let's take a look at an example of this method. Start with this argument. If it's raining, then the streets are wet. It isn't raining. Therefore, the streets aren't wet. Now, I hope you recognize that that's not a valid argument. It's an example of denying the antecedent, which is a fallacy that we've looked at before, at least briefly. However, we want to try to apply the counterexample method to it. So, what we need to do is first, we have to identify the form. What's the form? That's pretty obvious. The form is something like this. If A, then B. Not A, therefore not B. Now, what are we going to do with this form? We're going to try to find a case in which there are well-known truths for premises and a well-known falsehood for the conclusion. And interestingly, the most straightforward way to do this is to start at the end, to start with finding your well-known falsehood, and then try to figure out a way to fill in the premises. What we're going to do is we're going to start with something to represent the not B. How's this? Therefore, Obama is not president. That's our therefore not B. So now we know what B stands for. B stands for Obama is president. Now we need a well-known truth to have the form if A, then B. That is, if A, then Obama is president. What about this? It won't help us much to say things like, if Obama has been elected, then he's president. But let's try this one. If he was vice president in 2009 when a president died, then Obama is president. Is that a truth? Well, yeah, it is. If he was a vice president in 2009 when a president died, maybe Joe Biden won the election and Barack Obama was his vice president, then Obama is the president, because the vice president automatically ascends to the presidency when the president dies. So you've got something, a true statement that ends with Obama is president, an if-then statement that ends with Obama is president. Let's try another one. Can we come up with a truth for not A? Well, yes, we can. In fact, it's pretty easy. He was not vice president when a president died. Therefore, Obama is not president. There we have a counterexample to this argument 4. We have two true statements for premises. We follow the same exact form as the original argument, and we end up with a well-known false statement as the conclusion. Let's try another example. Look at this one. If I'm in London, I am in England. I am in England. Therefore, I am in London. Hopefully, you recognize that as involving the fallacy of affirming the consequent. But let's be a little more specific. What's the form of that argument? It goes like this. If A, then B, B, therefore A. Now let's see if we can apply our method, the counterexample method, the same as before. What we want to end up with is a conclusion, which we'll call A, and we want the conclusion to be a well-known falsehood. Can we do that? Sure. Try this one. Dick Cheney is a Democrat. That's a well-known falsehood. So our conclusion can be, therefore, Dick Cheney is a Democrat. Now the trick is, can we come up with true premises that would lead there if this were a valid form of argument? Let's try it. Since Dick Cheney is a Democrat is our A phrase, then we want the first premise to read, if Dick Cheney is a Democrat, then something. What could we put in there? How about this? If Dick Cheney is a Democrat, he is highly secretive. I think that's got to be true. If he's a Democrat, he's highly secretive, because everybody thinks that he's a Republican. Okay, so we've got a true first premise. What about a second premise? Dick Cheney is highly secretive. That's the B. And that seems true too. Everybody knows that he is famously secretive throughout the administration of which he was a part. He was always referred to as being at an undisclosed location. He was always working behind the scenes and rarely out in public. He is highly secretive. And so, we have two well-known truths and a conclusion which is a well-known falsehood. And that's enough to show that this form of argument is invalid. This is a powerful technique for testing for invalidity of arguments. It takes some work, but once you get used to it, you have a tool that you can use to show that certain arguments are invalid. However, as your textbook pointed out, there's a problem with it, at least the way we have presented it so far. The problem comes when we consider categorical statements. A categorical statement is one that relates categories of items or classes of items. For example, talking about all elephants or no zebras, or whether some giraffes are taller than 20 feet. These are categorical statements. They relate members of classes or classes of things to each other. Now, The problem with categorical statements is this. Consider a simple argument, a simple, valid, and sound argument. All UNC Pembroke students are human. All humans weigh less than a ton each. Therefore, all UNC Pembroke students weigh less than a ton each. That's obviously valid. It's obviously sound. Nevertheless, see what happens when you try to symbolize it using the tools that we've developed so far. You get something like this. For the first one, it's just a statement, A. There's no if-then, there's no two parts to it. It's just a statement, A. For the second premise, well, B. It's a different statement. And for the conclusion, well, therefore, C. Still another statement. The problem is that this is an invalid argument 4. What are we going to do? It's easy to come up with a counterexample, a good counterexample. Just put in it any two well-known truths for the first and second premise, and any well-known falsehood for the conclusion. You could say, there are some books in the library. That's sure one well-known truth. Here's another for the second premise. Grass is green. Conclusion. Therefore, the sky is made of black marble. That's a well-known falsehood. But it has the same form as this. And if we can use this to always detect invalidity, we would have to say that this argument, this obviously valid and sound argument, was not valid. What we have to do is we have to find a better way of representing arguments like this. Up to now, we have been talking in terms of statements. Our symbols have represented complete statements. A stands for a whole sentence, or it stands for a statement that's part of a whole sentence, like if A, then B. And B likewise stands for a whole sentence or a statement that's part of a sentence. It can be the consequent, the then clause of an if-then statement. What we need to do to avoid the problem, though, the problem that we just identified, is we need to introduce a richer, better way of symbolizing certain statements, and especially categorical statements. Let's take a look at our argument again. All UNC Pembroke students are human. All humans weigh less than a ton each. Therefore, all UNC Pembroke students weigh less than a ton each. Now, what can we do with that? What we need to do is we need to represent the fact that we're just talking about, say, Pembroke students and human beings. And those aren't statements, they aren't whole statements, but we need some way of representing that. In a way, it's pretty easy, pretty straightforward to do that. We can do it like this. For the first premise, we can represent it this way. All A are B. We let A stand for UNC Pembroke students, and let B stand for humans. Then the second premise is going to come out, well, all B are C. That is, all humans weigh less than a ton each. That is, they're all members of the group of things that weigh less than a ton each. Therefore, all A are C. That is, all UNC Pembroke students weigh less than a ton each. This is very similar to what we did earlier on when I gave you the example of Socrates being a man and all men being mortal, and therefore Socrates must be mortal. Now we can see how this can be valid, even though there's a misleading way of representing it where it turns out not to be valid. When you have the argument set up in this way, there are no counterexamples. So it turns out that this is a valid argument after all. Now, there's a great deal more that can be said about this, But the most important thing to do with this is not to say a lot about how it works or how one thing is connected to another, but to actually get some practice. And that's what I'm going to urge you to do. Take any examples of invalid arguments that you can find, whether they're assigned to you for this purpose or not. But take examples of invalid arguments. You have plenty of examples in your exercises. And see if you can make use of this technique for finding and constructing good counterexamples. Counterexamples where the premises are well-known truths and the conclusion is a well-known falsehood. I think you'll find that it will be very helpful.